So today is lesson 10, 10 of 12. So we've only got 2 more lessons after this week. And then we'll have our final exam, which I'm just going to talk about briefly right now. So Lakehead has updated the exam schedule online. You'll notice something weird here. It says our exam date. Here's our course. It shows as Tuesday, September 15th to Tuesday, December 15th. This is the correct date, December 15th. So that's just about 4 weeks from today, actually, is our exam. They are going to update this page to remove this Tuesday, September 15th. And our exam is going to take place at 11 a.m. that day. Okay, so it's not our usual class time. The exam will start at 11 and you'll have to submit by 2 p.m. And the format of our exam, if you remember at all what our exam was like in our winter course together. So I'll ask you to come to the WebEx room so you can use the chat to ask questions. And you should say signed in to the WebEx meeting. And just like in our PHP course, I will create several different versions of the exam. And then you will randomly be assigned one version of the exam. So the test is all practical. There are no questions and answers. And I believe, I can check the syllabus, but I believe it's worth 25% of your final grade. But it will be a practical assignment. Just while we're on the subject, are there any questions about the final from anybody? The format is obviously open book since you're going to be at home. We're not going to use any sort of proctoring software. Okay, well, I'm not seeing any questions. So make sure you do mark the date and time down in your calendars. So basically 2 weeks after our last class. So our final class is in 2 weeks, and then you'll have 2 weeks before you do your final exam. All right. So what are we going to do today? I want to go over assignment 2, part 2. You will be able to get started on it after today's class. We're going to talk a bit of a high level about unit testing. I know something you've looked at a little bit, probably in another course already. We'll go over the pattern of arrange, act, and assert. We'll talk a little bit about dependency injection and how it affects our ability to run unit tests in our .NET project. We'll look at mocking up our database. And then we're going to start writing some unit tests against our controller. So our unit testing, we're going to have 2 lessons. So we're going to kind of look at it from a high level today. We'll get our application configured to run unit tests, and we'll create some basic unit tests. And then next week's class, what we're going to do is basically have an in-class lab where in groups, you're going to write the rest of the unit tests. We're going to write a few of the tests we need today for our project. And then next week's in-class lab will be working as a group, and I'll kind of assign a different bank of tests to each group. And then I'll compile them all together. And then you'll be able to use that as a reference to do the second part of your assignment too. So I did make a couple of changes to the assignment document. I've uploaded them on D2L now. So the assignment is not due for 2 weeks, till Monday the 30th. So a couple things for part 2. First of all, I only need I really only need the repository link. You can include the Azure link, but for this part of the assignment, your application does not need to run on Azure. So now that I've marked everybody's assignment 2 part 1, you can go into the Azure portal and you can stop the web application. So it will not be using your credits right now. We'll need it again for part 3, but you won't need your site running for the next couple of weeks. So you may as well stop that. So again, you can give me the Azure link. It's not really necessary. I really just need the GitHub link because for part 2, I'm going to need to run everyone's project locally. So you're really just going to upload your version of your project with your unit test. You're going to upload it to your repository where you are creating a unit testing project in the solution, and you're creating a unit testing class for one of the controllers in your app. You're going to write unit tests to get close to 100% code coverage. So that'll be somewhere in the neighborhood of about 23 unit tests. You may need a few more, you may need a few less. So we'll probably write 5 or 6 unit tests today, and you can use those as a model for your assignment. And then the other 15, 17 or so that you'll need for your assignment, we'll do those together for our in-class lab next week. You only need to make a couple of commits to GitHub. You don't need to update anything in the README file for this part of the assignment. Okay, so you have 2 weeks to do it. You won't be able to complete the whole assignment over the coming week, the first week, because we're going to do more on unit testing next week. But if you want to get started on part 2, certainly many of the things we're doing in today's lesson, you can start to implement in your assignment 2 for part 2. So if you can have a look in the week 10 folder, there's a link here. I'll put it in the chat as well. A link to a quick whiteboard, online whiteboard. It says, what do you know about unit testing? So I want you to open that item up and follow the link. You do need to sign in, but you can use your Lakehead account. I'll put the link in the chat as well. So let's open this up. Should be able to sign in. For some reason, it doesn't work for me in Firefox, which is annoying, the Google sign-in. I am signed in here in Chrome. And I had a label here, which just seems to have disappeared. Hang on, I might need to generate a new link here. Okay, my mind map isn't going to be very useful. Yeah, you know what? We'll just use the chat box. This isn't working very well. So um, use the chat box and tell me what you know about unit testing. I think unit testing shouldn't be something totally new. So I'll just close this because it's useless. But we'll adapt. So what is unit testing? Why do we use it? Okay, it's a way to test if software is functioning as expected. Yep, that's true. What else do you know about it? Okay, yep, you got it, Bensei. So we'll check if error handling is there. Yep, does it meet our design and does it behave properly? Yep, all true. Anything else that you remember about unit testing? What's the difference between unit testing and other kinds of testing? Right, Oase, that's a great answer. That's really important. So unit testing is very specific. We're not testing large processes on the whole, we're testing individual components, a specific part of the code. That's a great answer. What are some other kinds of testing we might do besides unit testing? If unit testing is testing a really specific part of the code, there's 4 or 5 other common types of testing. What would some of those be? Aiden, I'm not quite sure what you mean by that. You may be on the right track, but maybe you could you expand on that a little bit? Do you mean testing between components? Right. So, okay. So integration testing would be testing between components. So Aiden, maybe that's what you were referring to, possibly. Okay. So let's think about our application right now. What are some of the components, different components that we could test between? There's really, I would say, 3 or 4 main components we're using in our application. Okay, so yes, there's some integration between the models using controllers. There's also components we're working with outside of just the Visual Studio web application. What other components are we using? Yep. So we're integrating with Google API. That would be one. What other components does our web application integrate with? Yep, we've got Microsoft. And then what's the biggest component that we set up outside of Visual Studio that we've been working with really right since the beginning? But this component is not inside the web application. Right, our database. So anytime we're testing, working with the database, between the database and the application, that's not a unit test. That's in fact a form of integration testing. So yeah, we've got functional testing. We might have user acceptance testing. So a lot of those are kind of more at the macro level. So today we're really looking at, as Awais mentioned, the specific unit by unit testing. So really what we're doing is we're really looking at testing one method at a time for all possible outcomes. That's really what we want to do with unit testing. So let's look at an example. Let's open up our beer store application. And we'll get it running. So I'll just launch the store. So unit testing is designed to do a couple of things for us. Let's have a look here. I'm looking at the products controller. Here's the details method that we didn't change last week. We just made it public, right? This was our product, showed our product details page to a customer. So when we went to the store, and I chose a product, right? It called our product details method here. So we customized this page a little bit last week. So here's our method. So if we wanted to fully unit test this method, how many unit tests do you think we should write? How many possible results could there be from this method? Take a look at the details method. Okay. Stella, true, but I guess we're more looking in general that we get the same kind of result. Leo, you're on the right track. You're getting warm. It's not actually two results. So what are the three scenarios? There's actually three different scenarios that could occur when we call this method. So here's the first scenario. The first scenario is we call details, but remember, ID, it's an optional parameter. There's a question mark. So we could call details without passing an ID, right? In my browser, I could call the method this way and leave out the parameter. So that's one possibility. So we need a unit test to make sure that if the ID parameter is empty, we send back a not found response. So that's one test. In this instance, we have an ID, but that ID does not exist in the database. So that would be a call like this one. Right? I am passing in an ID, but we don't have that record. So it's really a different condition. It's the same type of result in both cases. Both cases it's not found, but these are different scenarios. No parameter at all, or a parameter that doesn't exist in the database. The last test would be, the last possibility is the ID exists and it's found in the database. So something like this. So to fully test this, we need at least 3 unit tests, potentially 4 unit tests. Because the other thing we could check, here there's really 2 things happening, right? We could check that it returns the view called details. We want to make sure it loads the right page if we have a valid ID. And then we also want to check that the product object that gets returned matches the ID parameter that was coming in. So we need 3 or 4 tests for this. And as a general rule of thumb, each unit test should only test one specific thing. We don't want to be testing multiple conditions in one unit test. We're better off to break those up into separate tests. So not only does the unit test help us write good code, make sure that we've covered all of the scenarios and responded to each scenario appropriately, so our program does what we think it's going to do. I think, Bensei, you mentioned, if errors occur, that we're handling them properly. But this also helps us maintain our applications later on, even once our applications are in production. How do the unit tests help us maintain our application code? What's the value in unit tests for a production app? Yep. The other thing that the unit tests do, so Leo, that's true, and that could be true though either even before an application is launched or once it's in production. But the big value post-production is once we make changes to the application, the unit tests will help show us if we've broken things that used to work. So once we make changes in a production application, we can run the unit tests all over again and make sure all our tests pass. Because it's common practice that we make changes to code and things that used to work are now broken. So the unit testing helps identify those issues before we build and compile and launch changes. So Visual Studio contains a number of libraries and frameworks. There's several different unit testing frameworks. The default one that's built into Visual Studio is called MS Test. There's also different testing frameworks called XUnit and NUnit. We're going to use MS Test. All of them do integrate quite well with Visual Studio. So a little diagram here. About a unit test. So we've got a single piece of code or a method, and we want to test behavior within a function. So what we're going to do in class, this tutorial series is sort of old. It's based on an old version, but it's a good series from Visual Studio Magazine, which is a great resource for .NET developers about writing unit tests. Now, this is actually based around test-driven development. which unfortunately we don't really have time to look at. But the unit testing, this is a good reference for you. Has anybody worked with test-driven development or TDD before? Do you know what it is? It's a way of developing that many organizations have adopted. From the name, what do you think it means? Test-driven development. Sort of has to do with the sequence of when you write the code and when you write your unit tests. If you don't know what test-driven development is, use your best Google foo and throw an answer in the chat. Yep, Bensei, you got it. So the idea of test-driven development is that we actually write all the unit tests first, and then we write the methods afterwards. Why would we do this? What's the benefit of writing your application code this way? It's a very different way of thinking about software development. Why would you write unit tests first? Yeah, it definitely reduces the debugging time, for sure. Any other reason you could think to write your tests first and write your code after? Yeah, exactly, Bensei. So it forces us to think through all of the possible execution paths our code can take before we write the methods. Basically, is forcing us to plan out everything that can happen in the application, and we write the unit tests first. So the code is designed to meet all the parameters defined in the unit tests. If we had more time, this would be something we could look at doing, is actually implementing TDD. It's a little late for that in this course because we already have a working application. There's some great resources online. Might be something, for example, worth checking out on LinkedIn Learning. Do a 1 or 2 hour course on TDD. Because many of the places you guys are going to go to work are going to use this pattern. It's become more and more common. So understanding what unit tests are and how to write them is going to help you if you ever come into or work in an organization where they use a TDD approach to developing their applications. Okay. So let's look at unit testing within Visual Studio. So we're going to go to our Solution Explorer. And I'll just close my web project. So typically in Visual Studio, we actually create a separate project that holds all our unit tests. So I'm going to right-click my solution. Right now it says 1 of 1 project. I'm going to right-click it. I'm going to choose Add a New Project. And in this, up here in the search box, it says search for templates. I'm going to search for the word test. And this brings up a whole bunch of different options of templates for test projects. I'm going to pick this one. It says MS Test Project for .NET Core with C#. Now you'll notice there's 2 versions of this. One is Visual Basic and one is C#. Make sure you click on the one that's C#. We don't want to write our unit tests in VB. We want to write them in C#. So choose the MS Test Test Project.NET Core in the C# language. So I'll click on that template. And I'll just call it maybe beer store test. You can call the project name anything you like. Typically, we put the word test in the name so we can distinguish between the web application and the testing project. And I'll click create. So now in my Solution Explorer, I've got two projects. Our main or our startup project, it shows in bold. There's our web project. And I've got my beer store test project. And it gives me a class called Unit Test 1. It looks pretty much like a regular class, except notice it has this test class annotation. And it's got a method here called test method 1 that has a test method. So this indicates this class is for unit testing, and this is an actual unit test itself. I'm just going to rename this class. I'll rename it to Home Controller Test. And I'll rename my file as well. So my unit test 1, I'm going to rename that. I'll call it Home Controller Test. I'm going to rename my first test method. And our unit test names should be descriptive. They should include the name of the method we are testing and the result we are expecting, or the condition that we're testing for. So I'll call this index for the moment, returns result. So we want to call the index method of our home controller and make sure that it returns something. So in my Solution Explorer, here's our home controller. We didn't build this, so this was created by Visual Studio. So we want to test our index method. And it just returns a view. So all unit tests, we basically have 3 steps. And this is not specific to .NET. It's the same in any unit testing framework. I believe you guys have done a little work with JUnit before in one of your classes. Is that right? Yeah, was that with Jarrett? Okay, great. So the 3 steps in .NET, they're the same in Java. First, we arrange, we set things up. Then we act, we execute the method we want to test. And lastly, we assert. We state what result we are expecting, and we check if we got the expected result, yes or no. If we do, our unit test is going to pass. If the result is not what we were expecting, the unit test is going to fail. So the first thing we want to do is instantiate our home controller. And we get this error. So we're in a separate project. So our class, our home controller test, it can't see any of the files in our other project. So we're going to have to add some references. So what I want, first of all, is we need to add a reference between our 2 projects. So I'm going to choose this option at the bottom. It says add reference to our COMP2084 beer store. So I can do it through here. I can also do it through my Solution Explorer. So if I go to my dependencies of my unit test project, I could add a dependency by right-clicking. If I choose Add a Project Reference, I can then select the other project in my solution. So now the unit test project can access our web application project. So I'll click OK. So now there's a reference between them here. Now I've still got an error. So that was step one. Now I need to reference the controllers. So now I've got a reference. So that's my second error is gone. The third problem is the constructor in our home controller, it's expecting an object, a logger object to be passed to it. There is no empty constructor here. So how could we fix this? Guess we've got a couple of options. There's two ways we could fix this error. So we want to test the home controller in the web project, but the constructor that's here requires a logger object. So what are our two potential fixes here? And Visual Studio is giving me one of the fixes. What's this suggesting we do? Yeah, John, we could just supply a logger object. Okay. So let's do that. So we can just probably declare it the same way. Let's see. We need to make a reference to the logger class. Oops. Sorry. Okay. You know what? For the moment, I'll leave the logger out. I'm going to find the other suggestion, just for simplicity. I'll just take out this. And the suggestion it makes here is we could generate a constructor, an empty constructor. It's okay because we're not really using the logger class. So this just created this empty constructor. We don't need the logger right now. So I will just leave it out. So now I want to call the index method. So we'll call index. And we just want to check that the index returns something back. So we can assert that our result is not null. So we're going to instantiate an instance of our controller. We're going to call the index method, store whatever comes back in this result variable, and then we want to check that we get something back. To run our tests, so I'll just save everything. I'll click on the test method at the test menu, and I'll choose Run All Tests. This is going to build the solution. It's going to run our unit tests, and it will open up a window here called the Test Explorer. So the Test Explorer is going to run, and it tells us that our home controller test passed because our index method returned something. Okay, thank you, Leo. I'll grab that in a second. I appreciate that. So if we want to see, okay, well, what is this result? I could run this with a breakpoint. And now I'll right click and say debug my test. And we can walk through the unit test. And then I'll try it with the logger. So it calls index. You'll notice now what Visual Studio does that's kind of neat. It tells us on the index method in the web project, there is one unit test covering this method, and the last time it ran, that test passed. So our index method returns a view. So when we look at our result now, we get a Microsoft ASP.NET Core MVC view result. Now this is interesting though. Notice the name is null. So it did give us back a result, but it doesn't know the name of the view. Shows as null. So now it checks that this is not null, which it isn't. So our unit test passes. Okay, I think what I'll do is I'll leave this version of the test. I'll create another method and I'll try Leo's code and we'll rename it. So let's add another test method. Void index with logger returns result. So Leo, I'm going to grab your code. Okay, so you instantiated with the logger factory. Great, thank you. So this time we're going to arrange what we're going to call the original version of the constructor that takes a logger. Now we're going to act. We'll call this controller index method again. So again, we want to assert that when we call the index method, we get some kind of result back that isn't null. So I'm going to run my tests again. I'll go back to Test Explorer, and both of them pass. If we go and look at the home controller, it now tells us that there are 2 unit tests that call this method. Now there's also a tool in here, and you've probably seen a similar tool when you were working in JUnit. Now there is a live unit testing. So if you turn this on, anytime we change code in the controller and save, it automatically runs our unit test. We don't have to manually do it. So we could turn that on. There's also, under the test menu, the 4th option here is Analyze Code Coverage for All Tests. So let's click on that. Builds everything again. And now it shows us, if I open up my beer store project, it says there are 3,552 code blocks that are not covered by unit tests. 7 are covered. So if we drill down and go to the controllers, in the home controller, you can see our index method now has 100% code coverage, right? All of the paths of execution in the index method, they're covered by a unit test. And even better, if we go back here, there's this second last button on the toolbar says Show Code Coverage Coloring. If I enable that, you'll notice now in our home controller, our constructors are both blue. So our index method, because it's 100% covered, it turns blue. Our privacy and error methods are red because we haven't written any unit tests to check for these. So if we write a privacy unit test and we run the code coverage again, this should turn blue and our code coverage should increase. So overall in the controller, we've covered 31.82%. But we're covering the constructors and index. So let's add a test for privacy as well. So we'll add another test method. Privacy returns result. And we're going to run all the same code we did on the index with logger, except instead of calling the index method, we're going to call the privacy method. So we can copy the method above, but this time we don't want to test the index method, we want to test the privacy method. So I'll change my method call. I'll go back to my test explorer. I'm going to run all my tests. Which pass. Now, unfortunately, this code coverage window has annoyed me for years. There's no refresh option. So you've got to go and run it again. So you have to go to Test, Analyze Code Coverage, and it's going to compile and run the tests again, and then I've got to drill all the way back down, which is annoying. Turn my color coding back on. Controllers. So my home controller is now up to 45% coverage. So privacy is now 100% covered. Index is 100% covered. It's only the code in error. So privacy is now highlighted in blue because it has 1 of 1 passing tests. So in your assignment, you're going to use the code coverage. What I want you to do for assignment 2, part 2, is I want you to write all the unit tests you need for one of the controllers in your project. You don't have to unit test both of them, but one of the controllers you scaffolded that has create, index, details, edit, and delete methods. You need to write all the unit tests. So for example, for your details test, you're going to have 3 or 4 unit tests. One testing this scenario, one testing this scenario, and probably 1 or 2 tests for this. We're going to write one more quick test on privacy, and then we're going to take a break. Sure, no problem. You never have to apologize for asking a question. It's under test. It's this 5th item here, Ryan, the analyze code coverage for all tests. That will build your app and run all your unit tests again. And then you can just start drilling down into it. And to see the code coloring, you just enable this second last button from the right. They really, really need to put a refresh button in here, but I've used this window for years and I'm still waiting. You don't have the code coloring? Okay. If you don't have code coverage, go to Help and About. Are you on Community or Enterprise? That's why. So that's, I think I said at the beginning of the semester, you can use Community and it works, but there was 1 or 2 features it lacks. This was the main one. Now there may be some other unit testing extensions you can look at. I'll have to do some digging. There used to be one called AxoCover that I don't think exists anymore. So it was an alternative for community users who didn't have this built in. I will look and see if there's an alternative extension. So if you've got community, you won't have access to it right now. It won't prevent you from running the unit test. It's just helpful to have. So I'm just going to copy this method and change. So instead, we're going to say privacy loads privacy view. So the arrange and act are all going to be the same. But in this case, I want to check that the name of the view we get is actually called privacy. So in this case, I'm going to cast what comes back as a view result. So that we can check the name. And I'm going to need to add a missing reference here to Microsoft.ASP.NET Core.MVC. So now in my assert, rather than checking it's not null, I'm going to say assert.are_. So I want to check that the view name is called privacy. So we know it returns something from this test. This test already passed. But now we're casting the return. So our method returns an iAction result. So we're going to cast that as a view result. And then we want to check the name and that the name is equal to privacy. So I'm going to just right click and run this test. But this time, so notice I get green check marks beside my other tests. This test fails. Why does it fail? My assert are equal failed. I expected privacy, but the view name that came back was null. There was no view name. That's weird, right? When we click on the privacy link and call home/privacy, oh, okay, I guess I better, we've broken the application. I guess I better take out my other constructor. I'll just take out this constructor. And I'll take out our first test, which we need the logger for all of them. So home privacy should load a view. I'll make sure I fixed it. So it loads privacy, but my test fails. So it tells me my result.view name is null. Let's look at our privacy method. So in the browser, the privacy view loads, yet when we check the return, the object returned here, it says the name is empty. How could we fix this? So it works at runtime, but our test is still failing. What could we do here to be explicit about the name of the view that this method returns? We can add something to our privacy method in the controller. Because we don't want to return just any view, we want to return the privacy view. Any suggestions here on line 28? How do we specify the name of the view we're loading? You'll need to do this in your assignment for your unit tests to pass when they return views. What I want to do here is specify explicitly the name of the view I'm going to return. And if I run my tests again, now they both pass. And both my tests are passing. And now my red X turns green. So all of these return view statements in our scaffolding, like here we're returning a view called details, here we're returning a view called create. In your assignment, you're going to need to specify the actual view names in those return statements, or your unit tests won't pass. It does work in the browser, but it's not explicit enough. So whenever we're returning a view, we should be including the name of the view specifically. So we'll leave this controller. We've got 4 working tests. It's 3 o'clock. So I'm going to pause here and push what we've done so far up to GitHub. We'll take a 10-minute break.